So thank you all for joining us. And I guess we'll go ahead and get into it. So a couple of LinkML updates. The first one is that on May 20th, we released LinkML version 1.11.1. And that had like a fair number of new things in it. So we encourage people to, and a lot of bug fixes. So we encourage people to upgrade to that when you have the opportunity. Related to that, yesterday I just released LinkML Map, a release candidate for testing. I would really appreciate if people could give that some testing. I'd like to get it released in the next few days as a real release, not least of which because I have 2 downstream packages waiting on releases for that. So activity over the last month, we had 65 PRs created, 43 PRs merged, 19 authors, 15 reviewers, a bunch of issues, a bunch of them closed. 41 unique contributors last month. So that is pretty exciting to me. That just shows the vibrance of this community. And as Sarah mentioned at the bottom of this, I'm going to read it so people know, we're floating the idea of a virtual LinkML workshop where we get like-minded people together for show and tells. And so if you have an interest, please link that on the discussion.
Also, I'll just note that we will be creating an official registration form and things like that for once we get the dates set for the fall, but it won't happen until the fall.
All right, go ahead. Some fun recently closed PRs. Some new BigQuery generator stuff. RustGen is improving JSON schema stuff, Java, protobuf, lots of great stuff in generators. As I mentioned, LinkML Map had a release, and in there we fixed a bunch of stuff and added a bunch of new features. I'm pretty excited about the direction of that. And for infrastructure, we now have a contributor hierarchy and a co-owners policy. I would appreciate if people in our community could take a little bit of time and look at our contributor and our code of conduct, not code of conduct, but uh, our other governance documents in LinkML. Some things have changed. Certainly, if you have a reaction to them, we want to know your opinion. But we're trying to sort of improve the overall governance and the understanding of that governance across the LinkML community. All right, go ahead. As a reminder, we have monthly LinkML office hours. So that's where core LinkML developers will be available to the LinkML community so that people can pop in and ask questions, give feedback, or support other projects. There's no agenda, just drop in. That is the first Thursday of the month at 2 p.m. And details there. Great. Again, LinkML is community driven. The majority of our progress right now really is coming from community contributors. We appreciate your contributions, your feedback, your just being a part of this community. So we're available on email, Slack, and GitHub. And please, if you need to be invited to any of those, you see the contact information down there. All right. So our first presenter is Anne Vu. And Anne is a bioinformatics engineer at Sage Bionetworks, which is a Seattle-based nonprofit and develops the Synapse Open Science platform. She is part of the Rare Disease and ARPA-H funded projects and works on data and knowledge engineering, AI application development, and external integrations. So go ahead and take us away, Anne.
Yeah, thanks for having me. I'm gonna go ahead and share my screen. All right, that's calendar. Right, so I'm on Nguyet. Thanks for the introduction. So for this presentation, I'm going to be talking about adopting LinkML Sage for one of the projects that I work on, the neurofibromatosis project. And so this is going to be about the migration to LinkML, building and maintaining our data model for this particular research community. And then the Beyond part covers a little bit on some of the other Sage projects and how their adoption went and how some of that is going. So this talk is broken down into three parts, the workflows, which will kind of show you, from LinkML source to what we're actually doing a little bit downstream. And I don't think, or I think there will be a lot of parallels you see with workflows with LinkML that have been presented previously. Our wins, are just things that we actually use and like about LinkML. And then work in progress is that bigger picture of like where LinkML is in the adoption. Um, so everything is on GitHub. So our work is there at NFOSI, NF Metadata Dictionary. Um, so, all right. So a little bit of context, this NF Metadata Dictionary is our shared vocab and schema for this NF data portal. Uh, so there's this screenshot there where you can see we collect a number of different resources that's contributed by and for the NF community. So there's a lot of data that's being deposited in Synapse and annotated. So a lot of that metadata we collect. So the data model really does a lot of defining standard templates for that metadata. So we cover a lot of different assay types, so sequencing, imaging, as well clinical data, research tools, and more. So from these templates that are defined in LinkML, we have this curation process. So there's this curation validation, and then, in the UI search drop downs that are really originating from our data model. So in Synapse, we have this curator app that we use, and I'll show that in kind of the workflows portion. And everything is sort of this maintained openly. So, workflows is GitHub. But again, I'll show that in a moment. So this might be an interesting evolution to talk about. And I don't know that if many projects start from scratch from Linkabout, or they've had to do a transform or migration from a separate framework. But we did not start with LinkML. So originally, when I joined the NF project in late 2021, what we really had was just this one Google sheet of vocabulary. And this was to conform to an internal tool at Sage called Schematic. Um, so, all the projects were recommended to use this format and to use the schematic tool for our curation work. Um, and so this Google Sheet, is updated, gets exported as CSV, and then you run the schematic tool commands on it to generate this JSON LD, and that's is used by uh, this curation app uh, downstream. So I think there were a lot of things missing in this format. It was really not that expressive. Um, to be honest, it was a little bit ad hoc, and it was easy for, many non-technical uh, data managers to update, but there were just, in terms of modeling and, maintenance, many things I was not thrilled about. So anyway, 2022, I was like, oh, okay, can we at least get this into GitHub? And we still have to use schematic tooling, but that's fine. We put it in GitHub, so it's kind of more modular, rise in CSV, bunch of CSV files. We have CI, but we're still doing checks and compilation through schematic. And then in 2023, I think that's where I took a more serious look at LinkML. I think it already been like around for, you know, a while at least. But that's just when I was thinking, well, let's just overhaul this and move to LinkML. So, I mean, it wasn't that hard, but I mean, the hard part was maybe trying to maintain compatibility, but it was doable. So, we transitioned. So just um, reformatted a bunch of our files, and then we put in the LinkML tooling and, CI, and basically updated everything while while also still maintaining compatibility with schematic, in that we can export to this NF JSON LD format still. So yeah, so now we're basically in the LinkML era. So starting from 2023 to now. And actually, it's just only this year that we're like, okay, we can remove all the rest that we still had around for schematic. But yeah, you can see what's in GitHub there right now. Uh, Screenshot from yesterday. So we have our, source files, this modules directory, lots of YAML, and our workflow, builds just some of the distributed products. So like, we still can get JSON LD. We build the turtle, but the main thing that we're actually using, or being generated, and we just use JSON schema, uh, is JSON schemas for those templates. So in Synapse, you can register your JSON schemas under your org. So you can create an org, and you have these standards as JSON schemas for your community. You can, register all of them. It's, open. And so we do that. So we have this NFOSI org. Um, we have a lot of templates. So it says here 69. That's gonna, that grows, uh, has been growing throughout the years. So then once you have this registered template as JSON in schema in Synapse, you can bind that to an entity in Synapse. So you can bind it to like a file in Synapse, or other entities really, and from there you create this creation UI. So someone can select which schema to use when they're curating data, and then go to our curator app, which looks like, here's a screenshot, where they can fill in information. So it does like real-time validation. So any of the rules that are in the source, it gets translated to JSON schema. Um, and like if then conditions, the enums are drop downs, and that's uh, you can see here. So there's also this, actually, you can't escape the AI assistant, we call it Curie, that can actually help in, or help fill in some of the metadata. So the AI chatbot can read the JSON schemas, so it knows what the standard looks like, and can advise our users, researchers on, what terms to use, or, um, what does this validation error mean? So things like that. And it can also just kind of there's a row that can just be filled like by a simple set. It can actually do that behind the scenes. Yeah, so this is our kind of our new curation application actually. So all right. And one of the things that we publish as part of our workflow is just docs. And I think this is where I heard of interest. So it our auto-generated docs actually of the templates that we maintain. I'm actually only showing the common templates, so it's filtered down to what's most used. Um, and one nice thing is since we just uh, build the turtle file from our source, we get a queryable model for in our Sparko Explorer. So that's actually pretty nice. And if other for other projects that use LinkML and create that turtle file, I think we can use that for cross-model comparisons. Like your template, how many things are you collecting versus ours? Or kind of that analysis when we put all the model outputs together for querying. So I think that would be really nice. Oh. So some things that we really like just transitioning from schematic, and it was kind of a low bar. Or there's just so many things that LinkML afforded that our prior framework did not. Um, so definitely make use of this contextual usage, the slot usage. So we have for file formats, the range could be a union of all these different sets. And then, for a particular template, we just put in like this is this data can use this specific set or a combination of sets or whatever. And so for two, the rules translate really well to JSON schema. So the preconditions and postconditions. So here, I think this is just we're collecting information for what tissue type or the sample type actually. If it's saliva, you don't have to specify what organ it's from. So, but if it's like something else, then you have to specify like the site. Um, and we do actually make use of the meaning for ontology grounding. So that's kind of one of the maybe more unique things about LinkML. Like there's awareness of, yeah, we do want to add semantics. How to do that easily is in there. So as much as possible, we are including mappings to standard ontologies, and that's used for later harmonization. Because to be honest, a lot of projects have grown independently and they use different labels for things, but we'll all be going back and um, sort of doing harmonization. So this helps a lot. So here's the bigger picture. I've talked a lot about NF project, but Sage has a lot of different communities. So here's an overview. We have um, Alzheimer's community. We have, kind of more immune focused community, longevity focused, ALS. So of these different projects and portals at Sage, three are working with LinkML already. So that includes us and NF and HTAN. So that's the Human Tumor Atlas Network. So they also started, I mean, from schematic and in H10.2, now use LinkML, and ALS with it. So ALS uh, is lucky in that they started from scratch from LinkML, so they didn't have to worry too much about, migration or backwards compatibility and all that. Um, uh, so this migration though is not, so it's more difficult for some than others. And I right now our Alzheimer's community, so the team there is sort of been evaluating, trying to migrate now. And so there's lots of discussion. And actually, if Julia is here, um, she is really interested in LinkML. And yeah, if you have questions about that, and Julia is willing to talk about the AD migration, we can um, expand more upon that. Um, so yeah, so I think that's it for me. Um, if you have any questions, thanks.
Thank you, Ann. That was excellent and just so exciting to see what's developing there and the amazing community work. Um, yeah, so let's open this up to questions. I guess I'll go ahead and get started and I'll ask this, Anne. If I had my LinkML schema um, and I wanted to browse some things on Synapse, can I just bring my own schema to Synapse and upload it there and start to work on my own data?
Yes. So you just need to register an org, and anyone with Synapse account can do that. So you create an org. Like let's say you're a new community. I don't know what you want to work on. An example. And you have standards. You can, I can again, if anyone is interested, definitely help with that. But yeah, you can register your JSON schemas built from LinkML, and then create the UI in Synapse Curator with that basically provides you the curation interface for whatever template.
That's so cool. Thank you. I see your hand up, Harry.
Yeah. So yeah, first of all, thanks for the presentation. But I did want to mention a couple of the resources that I've been working on for the past couple of years with a lot of help from Sage and the Synapse platform as part of the Bridge to AI consortium. One of them is one that I linked in the chat here called the Bridge to AI Standards Explorer, and that's a collection of more than 1,000 resources now relevant to biomedical data standards, including their AI applications. That's the big focus of the Bridge to AI program. But yeah, all the source files for that are all in LinkML. It's a LinkML schema, and even the things that we are the separate standards that we've been developing, like data sheets for data sets, are also written in LinkML. So it's pretty much LinkML all the way down and starts off as YAML. So yeah, very similar procedures to what you illustrated for the NF dictionary and data portal, as well as the other resources. But I just wanted to highlight those since I don't know, we just don't tend to get the same kind of publicity. I know different teams have been working on different
Oh,
projects at Sage, and I don't know how much they talk to each other.
oh
So
yeah,
I
sorry about that. You know what? I think we need to include you in our the slide with the other portals. Yeah, so yeah, the Bridge to AI portal is on Synapse, and definitely, yeah, you guys do use LinkML. Um, but yeah, you're not on the um our listing, but we should add you. But yeah, I do think Bridge to AI is really great. So thanks for bringing.
yeah. I just wanted to mention it because yeah, it's yeah, it's another good example of that. Thanks.
I
Yeah.
see Melissa's hand up.
Hi, Anne. Thanks for so much today. It's really exciting to see after, several years of engagement with Sage on some of our LinkML stuff. So really exciting to see. I'm curious. So one of the things that we've been sort of noodling about for a while, is the idea of kind of a common data model that sits above a lot of the models within the clinical research data ecosystem. And I'm curious if you've had the same idea because you have a lot of similar clinical research, projects that you showed. Are they sharing common schema, kind of a common Uber schema, for lack of a better word? Or have you thought about that? And I'm happy to show you what we've done so far. It's a bit emergent, but we've basically like, if you look across these different clinical research repositories, like everyone's modeling the relationships between, a biosample and a patient differently, right? But the reality is they're all kind of the same. It's just, and what we're envisioning is sort of an Uber model that could then be extended for any given research domain. And I'm curious if, since you're one of the few groups that's got multiple clinical research projects going, if you had also come to that realization, or and if not, could we please work together on that?
Yeah, that's a great question. So there is a clinical working group at Sage um, trying to improve our clinical data modeling. For NF, I'm going to be honest that we struggled with trying to have a common clinical model because we can't actually enforce what data contributors are collecting. So they, come to us and they're like, well, my study is already funded to collect this, XYZ. And we try to harmonize their data, of course, but they already have their, you know, data dictionary and their, particular variables that they're interested in. So I think the best we can do is, I mean, we could figure out like what is like very minimal, but it's been pretty difficult to, I think, surface this um, like a well enough fleshed out common clinical model for NF. And also because, in NF, there's there's a, very domain specific clinical data being collected. So we have to be defining sort of new things all the time, like, oh, this is a new manifestation or new tumor type. And uh, so that might not even tie back to an existing model or ontology or whatever. So, um, and so one group will make this argument that this is what we should be collecting and this is a new thing. And, another group will have their own opinions. So that's where I'd say it's just within the NF
Yeah.
project. And you're trying to collect the same clinical data across different diseases, then yeah, it's challenging.
Yeah, maybe we can follow up, and I think it's a little simpler, or at least what I was envisioning is a little like, yes, the arguments, whether it's an ontology or a variable, the number of people who are going to disagree is there's some kind of proportion to the number of patients in the repository, I think. But I think this upper level idea is sort of almost like, Cobb is to the Obo Foundry, this idea of a clinical research kind of Uber model is to the clinical research LinkML implementation. So anyway, I would love to follow up on a discussion on that. I have to unfortunately hop off for another call, but it was really great to see your presentation. Thank you for coming.
Yeah, thanks.
Bye.
Bye.
Thank you, and Nguyet. I think we have to cut the questions off for now. But if anybody has any further questions, drop them in chat, and if we have time later, we'll let Anne uh, address those then. Our next speaker is Cory Levinson. Cory is an independent software consultant working in climate tech. He's the technical lead for the Ocean Alkalinity Enhancement Data Protocol, which is funded by the Carbon to Sea. which uses LinkML to support data sharing and metadata standardization for field trials in the marine carbon dioxide removal sector. He's currently an MSc candidate at UC Davis in their soils and biogeochemistry graduate group focused on soil carbon cycling and scientific data standardization in agriculture. So, Cory, thank you for joining us and take it away.
Great. Can you guys hear me?
Yes, I hear you.
Great. All right, let me share my screen. Is this coming through?
Yes, I see it.
Okay. Thanks so much for having me. This is yeah, I've been kind of intrigued and excited about the LinkML ecosystem since maybe 2020, early 2024 when I first came across it, and have been working on this project since September of last year, where it's been a great opportunity for me to really like get my hands dirty and try and figure out ways to take the work that you are all doing here with data standards and apply them to a domain that I'm more familiar with and been working in for a while, which is the carbon removal sector. So I'll start with just a little bit of background on, what that's all about, where that kind of comes from. I'll then talk about this OAE Data Protocol project, which is sort of the main crux of this work. Speak to how we decided to approach our technical tooling and why LinkML made sense as a kind of framework for us to underpin a lot of the software tooling for this work, and then and with a couple of opportunities and some of the rough edges that we've come across as we've been leaning into this, and where there may be some open questions. Yeah, and open to feedback on how we've been thinking about this as well. So to start, I think it's useful when folks are kind of not as deep in the weeds of the carbon removal sector to set the stage a little bit, that like we are at a time where the IPCC does have general consensus that while we do need to do like huge amounts of emissions reduction, we're not at a point where that is sufficient anymore to reach our global warming kind of targets of 1.5 degrees centigrade warming. And to get there, even if we are, let's say, getting rid of 90% of our emissions, there's roughly 10% of current emission levels that are expected to be from hard to abate industries or from other sectors where we do need to have some capacity for removing CO2 from the atmosphere. So from that has sprung up a lot of different pathways that folks are exploring. People hear about direct air capture. Folks maybe are familiar with other kinds of nature-based solutions. Marine carbon dioxide removal is a pretty broad suite of pathways, but I think that the general thesis behind this is that the ocean is already absorbing quite a large percentage of anthropogenic CO2 emissions naturally, and ocean alkalinity enhancement is really just one of these many different pathways being explored that leverage the ocean's existing capacity to sequester carbon through adding alkalinity in the form of dissolved minerals to the seawater, and thereby shifting the carbonate equilibrium and drawing down more CO2 into the ocean. So it's one of a number of different pathways being explored within marine-based CDR. Marine-based CDR is one of a number of different approaches that the sort of broader climate sector is looking at, and the general thesis is that we're kind of at a point where all pathways are being rapidly evaluated for both their safety, efficacy, and scalability. And so yeah, that's just, I think, some background for the work that we're doing, and where we're at right now with ocean alkalinity specifically. This is starting to hit the ground. On the right, what you're seeing is a project from the Woods Hole Oceanographic Institution. That was an NSF-funded project. They did their first field trial, I believe it was late last summer, and have some data sets that they've now produced. They're working with us on that data standardization effort for the data that they're going to be publishing and the research that they'll be publishing after those field trials. On the left, what you're seeing is a purchase of carbon credits. So this was a commercial deal where a conglomerate of tech companies put together an advanced market commitment of roughly $1 billion for carbon dioxide removal efforts to explore some of these different pathways. And this announcement from last year was for a $31 million kind of not pre-purchase, but they call them offtake agreements, where it's a commitment to purchase over a series of future years from this company Planetary, which is doing coastal ocean alkalinity deployments in Halifax, Nova Scotia. And both of these are examples of projects that are connected with our work. Carbon to Sea, as the funder of this work that I'm doing for the OAE Data Protocol, is one of the larger kind of nonprofit funders of research in this sector. And so they've got quite a lot of connections to the different kind of actors, be them academic groups or be them commercial developers exploring in this space. And so this is just a little overview from this group called Ocean Visions. They have a map of all of the different marine CDR trials ongoing, and this is just a filter applied to electrochemical and mineral ocean alkalinity enhancements. So what you can see here is that this is something that people are exploring. It's definitely a global research effort. And so, with that, there is definitely a need for us as a community to kind of be thinking about data standardization within this sector. So standardization, what I'm just saying here is it's important not only for the individual projects to be able to efficiently analyze results, but also for intercomparison across these different projects. And also, one of the biggest challenges with ocean alkalinity enhancement is that as it's what's called an open systems pathway for carbon removal, where the actual mechanism is something that happens in the open environment, and therefore the actual quantification and verification of the CO2 getting removed from the atmosphere is very complicated, relies on a lot of sensors, relies on a lot of data collection, and as this is a field that's looking to scale, is going to be in the future relying a lot on models, on biogeochemical models, and data being very easily being able to be integrated into those model systems is kind of a big importance for the field. So, if that's all sort of setting the stage a bit, it was, I think maybe in 2024 was when the Carbon to Sea kind of formally announced the initiation of this protocol. There was a consultancy, Submarine Scientific, who I'm working with. They're kind of the lead kind of project developer for the data protocol initiative, and they convened a series of workshops and feedback processes with the scientific community, all of the different researchers around the world who are working on ocean alkalinity enhancement, and together with NOAA, who actually formed a collaborative agreement with Carbon to Sea on the formation of this data protocol to leverage a lot of the work that NOAA had been doing for their ocean carbon acidification data system. So NOAA has a whole database and data system within their NCEI data system to store data around ocean carbon acidification. And so OAE, as kind of a more intervention-oriented research field, has a lot of parallels to ocean acidification research. And so there's a lot of learnings that we've sort of taken from that NOAA project and the folks working on that. Then in September of this past year was when I got more formally involved with the project, leading all of the technical tooling, translating what I don't have many slides on it, but it's very similar to what Anne was presenting earlier with the SAGE stuff, where what this group had done up until the fall of last year was produce a really robust set of spreadsheet templates, architecting and outlining the different kinds of metadata that should be collected from these different projects down to the data set level, and then where that was sort of handed over to me was to start thinking about how to create a suite of software tooling to make this a little bit easier for researchers and yeah, for adoption. So some of the key assumptions that we had when thinking about the tooling, I think one of the first things to think about with this project, and where it's maybe different from some of the other projects that I've seen, at least in the LinkML ecosystem, is there's no central data repository that all of these projects are necessarily going to be using. There's different use cases that will each have different data hosting requirements. Academic research projects will likely be using public repositories. Funders often dictate where projects need to publish their data sets. And then you have commercial field trials, which have purchasers of carbon credits. You might have verifiers. You might have registry bodies who are auditing data sets. and there's a very different set of requirements for data hosting and publishing there. So we're not, in a world where there's one central place where all of this data is stored. And so with that, we had to kind of think a little bit differently about like how we want to approach metadata standardization. So, what we landed on was really just having at the base level a portable JSON-based metadata file, with the thought that groups can, wherever they're hosting their data sets, attach this metadata file directly with their data package in whatever repository they're using. We then do also have conversations developing with the different data repositories as partners are starting to work with them to try and ensure that maybe metadata can be elevated easily into these repositories, search pages and stuff. But the main artifact that we're in the business of producing is this kind of standardized JSON-based metadata file, and a completely separate web app tool for researchers to use, fill out metadata, manage metadata, and then export one of these compliant JSON files for them to attach and upload elsewhere. We've also been working on verification tooling of the actual data set. So against a metadata file, which maybe constrains the kinds of variables that you say that you're tracking. So auditing whether it be a NetCDF file or an Excel file against those column headers. And then we've also been developing a discovery portal, which serves kind of as a meta repository for indexing all of the different data sets and projects that may be having their actual data stored elsewhere. Um, so why LinkML? Some of the reasons that I just wanted to highlight here: the flexible data model, having support for class hierarchies and mixins are all features that we've been using pretty extensively. In general, I wanted to take an approach that was very kind of schema driven. As much as we can encode all of our logic upfront into the actual schema and then generate artifacts or, like forms, web builder UIs, the better. The pathway that we've taken for our metadata builder tool is one where we're using JSON schema as our primary output from LinkML, and we're using this library called React JSON Schema Form, which takes care of a lot of the bare bones instrumentation around form generation. It integrates with some basic JSON schema form validation, live validation, and that's been a really useful kind of coupling of tools for us. Also, we wanted to be able to integrate with external vocabularies. So within the oceanographic sciences community, there's this NERC vocabulary server, which is hosted by the British Oceanographic Data Center, that hosts a lot of common kind of marine vocabularies in SCOS collections. And yeah, plugging directly into those and being able to use dynamic enums generated from those SCOS collections is something that we've been looking into and trying to make use of. Also mapping to other scientific data standards initiatives. So as I mentioned, part of our project includes a discovery portal. There's a lot of conventions from this group scienceonschema.org, from the ESIP community, around how data repositories and data sets that are exposing web resources can be standardizing data set discovery. And so we've been trying to make sure to integrate mappings to that where applicable. And lastly, this is something that's kind of been an evolving conversation with the LinkML community. A couple of folks here I definitely recognize from some of those calls we've had, but the NOAA group that we're using as sort of a blueprint for a lot of our work does most of their data management in XML and with XSD schemas. And so, to what extent LinkML is starting to look at XML interoperability and the ability to import XSD schemas into the LinkML ecosystem, that's all very interesting for us, and will definitely make some of our future integration with NOAA a lot easier. So yeah, getting into it, I think it's worth it to talk a little bit about just the hierarchical data model that we do have. The way that we're thinking about this initiative is that the metadata that's kind of contained within any of these JSON documents doesn't just have metadata at a data set level, right? We're describing a project at the highest level. If you think of Woods Hole Oceanographic Institution and that Loch Ness project that they're running, that would be the sort of single kind of project entity with a set of metadata that we would be describing alongside that. Each project can have a number of different experiments. So maybe there's a baseline study that they ran a few years before they ran their first intervention. There might be multiple different interventions in different seasons or different years, or different types of experiments that they run for certain kinds of monitoring activities after the fact. And then for each experiment, we have the ability to have separate different data set classes, where each data set, maybe represents a single sensor or a group of sensors. And that data set would describe all of the different variables that are collected within that data set, be it pH, carbonate variables, salinity, temperature, total alkalinity, etc. Yeah, I think it's worth talking a little bit about our use of mixins as well. With variables, things get a bit complicated for us. There's essentially two independent axes of variation that determine all of the different kinds of metadata that we're wanting to attach to a given variable. So yes, certainly, if you're measuring pH, there's a lot of pH specific information, like what pH scale you're using for this, for total alkalinity, for DIC, et cetera. There'll be specific fields that we want to capture for that. But independent of your variable type, there's your sampling mode, which is, in the ocean context, this is whether or not you were using sort of discrete bottle samples, where you're dropping bottle samples into the ocean and taking a kind of discrete sample, or whether these are from sensors that are continuous kind of underway sensors on a ship that might be continuously sampling over time. And the types of metadata that you want to collect, whether you're doing bottle-based sampling versus continuous underway sampling, are quite different. And so we have this cross product essentially, of these two different use cases, the variable type and the sampling mode, and have been able to leverage tools like mixins to really capture a lot of that complexity. So this is what our schema-driven metadata builder looks like. On the left, what you're seeing is the overview, where one can spin up kind of a project and describe a bunch of their project level data. And then they can, on this homepage, also instantiate a number of different experiments, and later on down, do the same for data sets. And what you're seeing on the right is this rendered web form. This is, we've been able to do a lot of nice custom theming with the React JSON schema form library. And one of the other nice things that they allow you to do is create, bespoke custom React components. So we have a map modal, or a map widget that you can see here on the bottom right, that when you click to edit it, it pops up a modal. You can drag and drop or move the map around to select your bounding box and save it. And that all, the modal stuff is custom JavaScript. It's this custom component, but at the framework level, it just hooks in as a React JSON schema form component that is paired to the specific slot that we're referencing in LinkML. I think that I'm doing okay on time, so I'm going to take a quick second just to pop open the metadata builder live and show you guys a few other things here. Can you guys see this now, the
Yes, I
browser?
see it.
Great. So what I'm going to do is I'm going to import a pre-existing data set. The way that we initially built this so far is there's no logged in experience. We're actually working on developing a whole login flow so users can have kind of persistent cloud managed metadata. But the initial MVP was really purely stateless. And you're just expected to kind of bring your own JSON file or export it at the end of your session. So here I'm importing a metadata file. I'm selecting, yep, I want all of these different data sets and experiments. This all gets imported. And what was nice here, and one of the things that I think illustrates that complexity that I was describing with the data set variables, is a little easier to explain when you actually go into the UI. So here we have the variables that we're tracking for this given data set, and within each one, we basically have a modal that pops up with this accordion configuration that is going to, depending on which variable type you select and which sampling method you select. So let me go back to, was I pH? Then you get all of these different accordion sections afterwards about QA, additional information, and the required set of these fields are all going to be conditional based on the combination of your variable and how you were tracking it. So that's one nice thing that's a little easier to show in the live UI. Okay, so back to the slides. Is this tracking right? You can see we're back to the slides now.
Yes.
Yeah, looks good.
Okay, great. All right, and so yeah, next I want to talk just a little bit about integrating of external vocabularies. So NERC, I don't know how many folks are familiar with this project, but it's pretty common within the oceanographic sciences community. Basically a vocabulary server specifically for SCOS collections in the ocean sciences domain, and they have a number of different collections published. Um, Particularly, we're using some around platform categories. So whether you're collecting data on a ship or off a coast, on a dock, from a buoy, et cetera, there's device categories and device catalogs where individual brands and serial numbers for specific sensor devices are cataloged in this server. There's also standardized names for sea names for the different ocean seas. And we're actually in conversations with this group about some of the ocean alkalinity enhancement specific vocabs that we're relying on with the NOAA team on creating some of those vocabularies to be hosted here as well. And as I mentioned earlier, on the left, what you're seeing is a preview of our data discovery portal. The hope here is that we're able to use standards like the scienceonschema.org group, which you're seeing on the right, and the way that they're kind of recommending scientific data sets and repositories leverage schema.org conventions to make data set discoverability and indexing into things like Google dataset search a little easier. So our hope is to be able to, kind of plug into that stuff where it makes sense as well. Yeah, and lastly, I know we're a little bit tight on time, but I thought it'd be useful to just talk through some of the things where we've hit a little bit of hard edges, or there's been some open questions that I've had and not really had the best answer of how to proceed. One is, so as you were seeing with the variable dropdown, right? There's a lot of detail in there based on these conditionals of which kinds of variable you're tracking. Well, when you load in a data set, if you don't have a type discriminator, it's really hard actually for the form to automatically know which UI it wants to render. So, LinkML does have support for type discriminators via this designates type meta slot. I was exploring usages of that, but I wasn't able to find that it was able to map directly to the JSON schemas in a way that would then translate into how React JSON schema form would expect it. Right now, this is not too hard for me to work around since our whole variable level modal is actually quite it kind of overrides a lot of the React JSON schema form logic, and I do a lot of custom work directly within there, so I'm able to kind of do that inference of the designated type and type discriminator stuff myself. So it's not too big of an issue, but something that might be interesting to look at for the generators as well. Um, on the enum side, this is kind of an open question that I've had is like, great, I'm making use where I think it makes sense of the meaning keyword, but before really looking into that in detail, I'd been assuming that I could be using something like the JSON LD context generator for JSON LD support. The challenge with that is that JSON LD context can't override values of a JSON data set. And so it makes it a little bit challenging if I'm trying to think of like a standardized JSON output and what the value should always look like for that. The last thing that I'll say is for NERC, that's a SCOS collection dependent vocabulary server. And, so when I was starting to work on that for support for dynamic enums, I was looking a lot at Oak and VS Kit, which is very kind of tied as I've seen it to like kind of the OBO set of ontologies and that kind of tooling. I've learned a lot from that, and I've been able to kind of develop my own set of Python tooling. But if there are other folks in the LinkML community wanting to have support for dynamic enums for non-OWL ontologies and things like SCOS collections, I'd be very happy to kind of connect with other people about that and maybe think of some ways to have like broader community tooling for SCOS vocabs for dynamic enums. Yeah, and lastly, the XML stuff is of interest, and yeah, excited to be tracking that as it evolves. So this has all been a big community effort. I've been leading a lot of the charge on the software side of things, but there were a lot of people involved in the community consultation process for the development of these standards and of the kinds of variables to be captured. So I want to give a shout out to the big group of folks who've been leading this, to Submarine Scientific and Carbon to Sea with their funding and steering support. So thanks.
Cory, that was excellent. Thank you very much for sharing that. What an interesting and exciting set of research there. I did want to, just because they happen to be projects dear to my heart, bring your attention to Schema Automator and LinkML Map as tools that might be something that you will find useful. I also, I'm using Schema Automator as an initial place to sort of explore XML based schema importing. I don't know how the rest of the LinkML community feels about the my using that as sort of the test bed, but that is what I've done. And I think with that though, we're at the end of the hour. I'm afraid we don't have time for questions. I want to thank you, Cory, and you and Nguyet, you uh, for presentations, both of which were wonderful and really interesting. As I said at the beginning of this is one of the things that's just amazing about the Linkable community is the incredible variety of research that's done, and the engagement and excitement of all the people who bring their research to us. So thank you very much.